Okay, let's take a look at this number 10. I did start it just for the sake of time and making this just a little bit quicker of a problem. So here's our equation, and it marks the distance in the movement of a light beam from the top of a police car across a wall where t is time in seconds and y is the distance in feet from the point on the wall directly across from the car. So holy smokes, what is going on here? Here's what we're saying. Here's your police car. I know I'm an artist. Okay. Here's the light beams and here's the wall, right? So the light beam's going to hit the wall, and actually I should put the wall like this. Okay. There's the wall. Okay. As the light is rotating, the beam is going to move this way. If it's going counterclockwise, it's going to go that way along the wall. So now let's suppose you're looking at the wall. So you're in the police car looking straight across the wall. Here's where the light beam hits when it's directly across from you. Okay. As the light beam moves, it's shifting this way. This distance that it is from this main point, this is the y value that they're describing in the equation. So this is the y value is dictating how far we are from that original point. Okay. Obviously, as the light on the car turns, this distance from the center gets larger and larger and larger. Okay. Now, at some point, the light is rotating and it's no longer showing up here at, let's see, it would be when it is a 90-degree angle. In other words, when it's pi over 2, and then it's not hitting the wall anymore, right? It's parallel to the wall, but then that there's a light beam coming this way and probably one that's shooting this way that's coming around from the other side, and it's a long ways away, and that one is going to approach that spot on the wall. Okay. So if we follow on the graph here, first we're right at that spot. We're 0. Let's see, what's my feet? 0 feet from that spot. Then it increases until you're at the time of 2 seconds, right? At the time of 2 seconds, the light beam from the top of the car is parallel to the wall, so it's not going to hit the wall. But up until that point, it would have hit the wall at a distance very far out if the wall was big enough. But then the light beam is coming from the other side at a very far distance and coming closer until it hits that spot on the wall, and it continues to move. Okay, this should go on forever. However, they told me in part B to only graph the interval from 0 to 5. So even though this would continue, period's 4. So that's 2, that would be 6. Even though there would be another asymptote here and it'd continue, they say stop it and only graph from 0 to 5. So that's why I stopped and I didn't graph that piece of it. Okay. Now, what they're saying, find and interpret the stretch factor and period. Okay. Well, the period is 4, and it's how long before it repeats. Well, that's 4 seconds. Okay. All right. Now, the stretch factor is 5. So what are they telling us? They're saying, basically, where is the distance 1 second after the light beam hits that center mark? And at 1 second, the light beam is 5 feet from that center mark. So that's what that A helps us find. And then C is find and evaluate f of 1, and we kind of already did that, but I'll show you it step by step here. 5 tangent of pi over 4 times 1. Well, this is 5 tangent of pi over 4, which we know is 1. So this is 5 times 1. So this is 5. What does that mean? At 1 second, the beam is 5 feet from the spot on the wall directly across from the car. All right. Okay, call it quits there.